Good morning, financial algebra. If you're watching this, this is for 6.2, modeling tax schedules. This unit is really important because if you ever make money, you need to file your taxes. So there's several important vocabularies that come up in here. Sales tax, progressive tax. Progressive tax is simply our tax rate increases as your income increases. So the more you make, the more you pay in taxes. The opposite is a regressive tax system, which is your tax rate decreases as your income increases. Here in the United States, we have a progressive tax system. Tax bracket is the only one I put in the notes, and this is very common. Your tax bracket is basically a percent that is assigned to your income amount, and that's what you end up determining whether you owe or are owed money back is whatever tax bracket you're in. That'll determine the withholdings. So we're going to go ahead and jump in and do some examples together. So here is Schedule Y. This is a filing status for married filing jointly. Remember that was MFJ. And so they've given us these this table, and they want us to be able to do three different notations. So there's the tax schedule notation, interval notation, and a compound inequality. So for this first one, it says over $0, but not over 18,450. So that is what our schedule is saying by this first line here, because it says over this, but not over this. And so I'm just writing that in words. Interval notation is to write the two as inequalities. So they're saying over 0, so x is greater than 0. And I'm just going to write a comma. And it says, but not over, so x is less than or equal to 18,450, because it didn't say anything about not equaling. A compound inequality is where I write this as one inequality. So here's how you do that. You write the smaller number first. Now this says x is greater than 0, so I'm going to put x in the middle. So I have to write it backwards. So you write it from right to left. So 0 is less than x, or you can read it backwards, x is greater than 0. And then x, I'm going to write the second part just the way it is. X is less than or equal to 18,450. Notice they both have a less than. I remember less than because it looks like an L. And it should be set up that way if you put the smaller number first. So I'm not going to do all of these, but I am going to do a couple so you get the hint. So over 18,450, but not over 74,900. So that is from this second one here. Okay. Now, as a notation, that would be x is greater than 18,450, but x is less than or equal to 74,900. So that's writing them separate. If I write them together, put the smaller number first for 18,450, and over here I would put 74,900. And x is greater than the first, but less than or equal to the last. Okay. So I'll do one more. So this is for this one. This is for this one. I'll do one more, and then I think that'll pretty much explain how to do this. And so this will be for this one. So this is saying it'll be over 70. Thankfully I have erasable pens. Over 74,900. But not over 151,200. Okay, so that's the pink in words. Now, if we write these separately, it's saying that x is greater than 74,900, but x is less than or equal to the second amount. Now, remember, if you write them together, write the smaller number first, so 74,900. Over here would be 151,200. And x is greater than 74,000, but less than or equal to. So that's how you would write that. I think you probably get the point with that setup. So number 2, let y represent the tax and x represent the taxable income. Use a past year's worksheet to write 4 equations in slope-intercept forms for values of x that are greater than or equal to 100. So I'm going to simply do these first 4. Okay, so and I can label them. So I'll label this one as number 1. So y equals, the percent is your slope, so 0.25x. You are subtracting this, so minus 56.7750. And that's it. So this is your slope. This is the amount you're subtracting, right? You're multiplying. So I'm multiplying. It says multiplication. So 0.25 times x. And then I'm subtracting the second amount. So number 2, y equals, for this income level, I'm multiplying. So 0.28 times x. And I'm subtracting 95.6550. Next one. So y equals, I'm multiplying my income. Notice the more you make, the more they tax. So now 33% minus 20,058. And last one. So this time 0.35, I'm multiplying that by my income, and then I'm subtracting 28,288. And it said to only do 4, so that's why I only have 4 written. All right, so the next one. So this might not be in your homework, but I want you to be able to do this. And so this is asking us to write a piecewise function for f of x for the first 3 taxable income intervals for a single taxpayer. So I'm going to do just that. So f of x equals, and I'm going to write that really big like bracket, and I'm going to do the first 3. So I'm going to do this one, and this one. All right, so in order to do this, I'm going to have to compute my equations. So for example, the first one I don't need to do anything. So it says 0.10%, I'm doing that top one, 0.10% times x when x is greater than 0, so when you make more than $0, but less than or equal to 92.25. Now, this next one, I'm going to have to take the largest amount I could have made in that category, which was the, wait, let me grab my calculator. If I take 10%, and multiply that by the most I could have made in the last bracket, that gives me, hold on, that's not it. So this, for this next bracket, it would be 922.5, which is written right here, plus 0.15 of x minus anything you made over 9,225. And so I have to simplify that for this next one. I know this is 0.15x, but I don't know the amount I'm subtracting by. So I have to simplify this. This gives me 922.50 plus 0.15x minus 0.15 times 9,225, and that's 1383.75. So that gives me 0.15x, 922.5 minus 1383.75, and I'm going to subtract 461.25. And this is for when x is greater than 9,225, but less than or equal to, this is number 2, 37,450. This next one, I know it's 0.25%, but I don't know what I'm subtracting by. So I would then take the last amount. So that tells me 56.25 plus 25% of any amount over 37,450. So I would have to simplify this. So I would end up taking 5156.25 and subtracting 25% of 37,450. And that gives me an amount of negative 4206.25. So minus 4206.25. And that is for when x is greater than 37,450, but less than or equal to 97,50. So this part here is my answer. And that's probably not going to be on your homework, okay? But I wanted you to see how that was done. I'm actually going to fix that. So number 4 gives us a marginal tax rate for our income levels, and it compares 1914 to 2018. So, for example, so if I said I'm in the 4% tax bracket, 4%, that means I make between $75,000 and $100,000. So what was the marginal tax rate for a taxable income of $40,000 in 1914? So $40,000 falls between here, so your tax rate would have only been 2%. It's incredible. What was the marginal tax rate for $40,000 in 2018? It's right there, right? $40,000 is in between 38 and 82, so 22%. So how much? I mean, that's a huge, huge, huge increase. So part C, based on the marginal tax rate, find the difference between someone making $90,000 in 2014 and 2018. In 2014, if you made $90,000, you would fall in the 4% tax bracket. Sorry, that should say 1914. In 2018, if you make $90,000, you fall in the 24%. So what's the difference there? How much has it gone up in the last 100 years? It's gone up 20%. That is a big increase here in the United States. Last one. Examine the following function by writing these in slope-intercept form. And so I'm going to do each one. So for example, we're just going to be simply distributing. So number 1, I have 14,652.50 plus 0.28 times x minus 71,950. Now to write this in slope-intercept form, you're going to get rid of your parentheses by distributing. So this gives me 0.28x, and then you're going to multiply 0.28 times negative 71,950, and I get negative 20,146. I'm going to bring down this term, and then I'm going to combine like terms. So in slope-intercept form, there's no other x's, so 0.28x. But I am going to combine these. So 14,000 minus the 20,000, I got negative 5493.5. Okay, number 2. So this next one, I have, 36,548.50 plus 0.33 of x minus 150. So again, I'm going to write this in slope-intercept form by distributing. So 0.33 times x is 0.33x. 0.33 times 150 is negative 49,549.50 cents. I'm going to go ahead and bring down this first term, and then I will combine like terms, right? So the only thing to combine are these two. So y equals the decimal x part first, right? That's your slope. Then combine these, and I get, right, we're combining like terms. And so 36,000 minus the 49, I got negative 13,001. Last one. So 94,727.5 plus 0.35 x minus 326,450. So Let's make sure we distribute. So 0.35x. 0.35 times the 300,000 is negative 114,257.50. Bring down this first number and combine like terms. So y equals 0.35x. 94,000 minus 114, I got negative 19,530. And that completes that section. It's not too long. Thank you.